The definition of irrational exponents states, for any natural numbers m and n, where n is not equal to 1, any real number a for which the nth root of a exists, a to the m over n power is equal to the nth root of a to the m, or is equal to the quantity nth root of a raised to the m power. Let's take a look at an example. Here we have the base 32 to the 2/5 power. Applying the rational exponents described above, this is equivalent to the 5th root of 32 to the 2nd power, or the 5th root of 32 raised to the 2nd power. This squared is going to be a much larger number. Either one of these can be simplified, but if we look here, 32 is a number, can be found as a number to the 5th power. 32 in prime factorization breaks down into 2 to the 5th power. It's still raised to the 2nd power, but now we have a perfect radical. The 5th root of 2 to the 5th power is 2, and then we'll deal with the square of 2 to the 2nd power for a final simplification of 4 to this answer. We would have found the same if we had taken 32, squared it, and then taken the 5th root as well. In this next example, 100 raised to the 3/2 power can be written in radical form as an index of 2, which means the square root of 100 to the 3rd power, or the square root of 100 and then raised to the 3rd power. Again, it's generally easier to take and simplify the radical and then deal with the power. And to illustrate where that 2 in the denominator of our exponent went, it's understood when you have just a square root that the index is 2. Either one of these, we can take 100 to the 3rd power and then take the square root, or here, square root of 100, what number times itself equals 100 would be 10, and then we will raise it to the 3rd power, which will result in 1,000 from 10 times 10 times 10 for our final simplification of this expression.